Okay, so this is my Daystate GCU version 5 drop-in replacement project. This is my GCU, Espressf ESP32 microcontroller, web server on it. This is the solenoid hammer from a Daystate pulsar rifle. We've got a current clamp looking at the current going through the solenoid. The power supply here is taking the part of the battery. It's around 10 volts at the moment. We've got an oscilloscope looking at the output of the current clamp, and up here we have the web interface that is running on the GCU. So I've got from the top, I've got the battery voltage, and this is reading 10.2, which is a little high, but yeah, okay. V boost, which is the charge on the capacitor bank, and that's the energy that will be dumped into the solenoid to actually fire the rifle. We'll come back to that in a moment. Pressure, well, there's no pressure sensor attached at the moment, so we'll ignore that. Now, the boost converter is the circuit that generates the high voltage that actually charges the capacitors, and of course there is the hammer strike duration time. Hammer time, how could I resist? So first of all, I'm going to set that back to 1200 microseconds, and I'm going to turn on the boost circuit. And fairly rapidly you can see that the capacitors are charging up towards 60 volts. And we're there, and now I'm going to fire the rifle. Bang. If we look at the scope, we can see a nice fat pulse of current, and that's about 400 millivolts peak, which on my current probe is around about 40 amps. So I'll just reset the scope. Go back here, go to 2000 microseconds. We're charged up, fire. And again, you can see that the current pulse is much broader. We're starting to deliver more energy to the hammer. Reset. And we'll go to 3000 microseconds, fire. And again, an even broader pulse. We're really emptying out the capacitors now. So I'm going to put this on to run, zoom out, and we'll just fire a few more shots. And tomorrow we'll put this in a red wolf. Okay, thank you.